Okay, so welcome to another thrilling installment of doing the gearbox. So in this case, what we're going to do this time, we're going to put the slot into the gear at the right depth. But the first thing I'm going to do is actually make an adjustment to this gear extrusion so that the origin is going through the center of the part. So the planes of symmetry are central about the halfway down this object. So if we just turn this on, you see, if I turn the origin on here, you can see it's on that back face. Really, I want it down the center. So there's a fairly simple way of doing this. There's our sketch. Okay, not that one. This one. That's causing that's giving us our extrusion. So what we're going to do is we're going to modify the extrusion. So edit feature. And instead of having it blind, what we really want to do is both directions. So I just remember that it's 28. So it's going to be mid plane, like so. And we're going to go 28 mid plane. So now the origin will be in the center, and that makes life a lot easier when we go to do any properties on the, if we were to do mass properties on this, if you wanted to know the radius of gyration or anything like that, you need to have the origin in the middle. Okay, so, and also when we go to assemble it all these planes can all line up as we go to assemble the whole system. Now the other problem now, of course, is that my hole doesn't go all the way through. So edit feature, through all, both directions. There we go. And now we're through all both directions. And if we check, that is our front plane. So we're going to use the front plane to do an extrude cut for our slot. Now if we remember the size of our key, it was 5 by 5. So let's have a quick look on the PDF. Here we go. It's going to be 5 wide across here, but we need this distance here, T2, for the depth of the cut from a plane that's tangent to the edge. So let's go and find our 5 by 5, and T2 cut into the hub is 2.3 millimeters plus 0.1 minus 0. So it needs to be between 2.3 and 2.4. So halfway between 2.3 and 2.4 is 2.35. And that's what we're going to do. We're going to set it up with a depth of 2.35. So it looks like, oh, and the radius is 0.25. So 2.35 will do for our depth, and it needs to be 5 mil across. And the tolerance is going to be on that as well, isn't it? So there should be a hub tolerance. Here we go, normal fit. Hub tolerance is a JS9. So we're going to go 2.35 for our cut. So how do we cut that? Well, we could draw a rectangle and measure it off of the edge of here, then off of the edge of there, and all that. And that's not a bad way to go. But really we need to be measuring from tangent face. Okay, so there's a couple of ways in which we could do it. We could do an extrude cut in both directions, or we could set up a plane and draw on that plane tangent to this face and cut up, but then you'll be left with a dangly bit. Or we set up a plane here tangent to the face, and another one offset by 2.35, and then cut back to it, or whatever. Or we could draw on this face, on this plane, on a plane, on this plane here. Where is it? On this top plane, and then extrude to the other plane. That's probably the best way to do it. Okay, but there's a whole host of ways in which you can do it, and there's no right way of doing it, but there are a lot of wrong ways. Okay, I'm going to go with probably the easiest way to do it, which is to draw on the front plane. So sketch, sketch. We're going to choose the front plane. There we go. Hit the space bar and go normal to. So you notice that with a lot of the things that I do, I'm drawing on these principal planes rather than on the geometry itself. That's because if you roll back the geometry and get rid of any of this geometry, which a lot of the time you do because you make changes to the geometry in your component design, you will lose the plane that the sketch is created on. This way, those sketches are never lost because they're always created on the principal planes, and you never get rid of the principal planes. So that makes sense, doesn't it? So I'm going to draw a center line straight up, like so. It gives me something to work from. And I'm going to draw another center line across here like this. So you can see this one's entirely blue. This has got a blue tip. What we want to do is to make this one tangent to this edge. Add relations. And we'll go tangent. There we go. And we'd already made it horizontal, so that's fine. So that's where we're going to measure the depth from of our rectangle. So we can now just set up a fairly routine, if we use a center rectangle and click on this line, then we know it's centered, so it can't go left or right, so we're fine there. We need to set our width, which is a nominal width of 5. There we go, there's our nominal width of 5. And then we need to set a depth from here to here of 2.35. Okay. And if you remember, we got that 2.35 from here, didn't we? So it's 2.3, so it's on the hub. 2.3 plus 0.1 gives you 2.4, so it's between 2.3 and 2.4, so 2.35 is halfway between. So let's go back to our model. There we go. So that's going to give us the right depth. And then we probably just want to constrain this to the center of here. So add relations, this to this, just to make it fully constrained. Okay. So there's our sketch. So the sketch is all black, so we know it's going to work, and that is going to extrude in both directions. And the depth is measured from a line that's tangent to this edge. So it's nice and easy to understand the construction on this. Features, extrude cut, through a wall both directions, click OK. And there's your keyway. That was easy.